Okay, so we're now going to look at two additional linear inequality problems. So our first one says 2x plus 5 divided by negative 3 is less than or equal to 4x plus 5. And so we want to start by eliminating the fraction. And so we're going to do that by multiplying both sides of the equation by negative 3. So when we multiply by negative 3 on the left-hand side, the negative 3's cancel out and leaves me 2x plus 5. Now, remember that multiplying or dividing by a negative at any point in an inequality problem is going to cause your inequality to flip and change direction. So this less than or equal to will now become a greater than or equal to. And then we're going to distribute the negative 3. So negative 3 times 4x will be negative 12x. Negative 3 times 5 is going to be negative 15. And from this point, it works like a traditional inequality now that the fraction has been eliminated. So our goal is to get the x's on one side and the numbers on the other. So I'm going to start by adding 12x to both sides. So 12x and 2x is going to give me 14x. Plus 5 is greater than or equal to negative 15. Then I'm going to move this plus 5 by subtracting 5. So we have 14x greater than or equal to negative 20. And then I'm going to divide both sides by 14 to get x by itself. So our inequality is going to look like x is greater than or equal to negative 20 over 14. Negative 20 over 14 is going to reduce. Both of those are divisible by 2. So that's going to give me negative 10 over 7. And it asked me to write the solution set in interval notation. So we're going to first maybe graph it just so we can kind of see what the graph looks like. I'm going to mark off the negative 10 over 7. And let's think about what direction we would want to shade. We want x values that are greater than that, which means that we're going to shade to the right. And because this has a greater than or equal to, that means we're going to use a bracket on the negative 10 over 7. So now once you have that picture drawn, then writing the interval notation is easy because we can see that the shading starts at negative 10 over 7, and that has a bracket on it. And the shading ends at infinity. And remember that infinities always have parentheses. So our second problem gives us the inequality negative 4 is less than or equal to 2m plus 2 divided by 2 is less than or equal to 12. And so again, our first goal here is to get rid of the fraction. And so we're going to do that by multiplying by our denominator. So we're going to multiply all three parts of this inequality by 2. And so we'll start on the left. Negative 4 times 2 is going to be negative 8. In the middle, when we multiply by 2, the 2's are going to cancel, leaving me just the top part of the fraction. And on the last part, 12 times 2 is 24. And so now we have this combined inequality that we'll just simply solve for m. Remember that we want to get m by itself in the middle, so we're going to start by subtracting this 2 from all three parts of the inequality. So negative 8 minus 2 is going to be negative 10. In the middle, we'll now have 2m. And on the outside, on the right side, 24 minus 2 is going to be 22. Our last step is going to be to divide by 2, and we want to do that on all three parts. And so we're going to end up with negative 5 is less than or equal to m, which is less than or equal to 11. And we want to write the solution set in interval notation. And so again, it may help you to draw a graph of it first. We'll put the negative 5 and the 11. And we'll remind ourselves that we would want to shade in between because that's where the m is located, in the middle. And so we would shade in the middle, and because we have less than or equal to's, we're going to use brackets on both. And so then as we move to our interval notation, we can simply pull it off our graph. We can say that the shading starts at negative 5, and negative 5 has a bracket. And the shading ends at 11, and 11 has a bracket as well.